Hello everyone, in this video we're going to be looking at solving harder trig equations, which is a really important key skill. Now the first thing to do is to look at the initial range of values that the question is asking for. So the initial range of values that the question is asking for in question 1 is that x is less than or equal to 180 but greater than or equal to 0. And so we need to change this range of values to reflect that in the question. So we have 2x is therefore going to be less than or equal to 360, just timesing that by 2, and then 0 times by 2 is still 0. And then we need to add on 60, so we're going to have 2x is going to be less than or equal to 420, which is going to be greater than or equal to 60 when you add on 60 to 0. And that is our 2x add 60. So what we've done is we've changed the range of values that we're looking for the solutions. Now, the second thing that I think is important to do here is to sketch the graph. I know that there are two different ways of approaching these questions. Either some teachers like to teach something called the cast diagram, but I think that it's much better if you can, and promotes a deeper understanding if we do it from actually drawing the graph. So what's our function in question? It's sine in this case. So I'm going to draw a portion of sine. Now there's up to 360, and I think we're going to need a bit more than that. So I'm going to draw a little bit more than that. Let's go add another 90 there, like that. Okay, so I've drawn sine there up to 450. There's sine from 450 to 0. And the question says is equal to 0.2. So I'm going to draw on a line here at 0.2, roughly 0.2, like that. And then 60 degrees, I think, is going to be, let's imagine, roughly somewhere like that. Now, that's our 60 degrees, and we're looking for between 60 and 420. So 420 is a little bit back from here, say 420. So this is our window where we're looking for solutions in that range there, in between our 60 and 420. And we can see by this method, which is one of the advantages of this method, that we've got two solutions in that range, okay? Because this one is actually out of range. So now we take our calculator and we're going to do inverse sine of the 0.2. So we're in degrees, we're going inverse sine of 0.2, and that gives me 11.53. Now that's what's called the principal value. The value that your calculator gives you first has a special name. It's called the principal value. So that solution there is equal to 11.53 degrees. Now in sine, again, this is part of the key skill of knowing how do we navigate from that principal solution to the other solutions. It does take students a while to pick this up at first when they first see it. However, what we do is we're going to basically say that that's 180, okay? So therefore this solution is 180 take away the answer that we just found by using the symmetry of sine. So 180 take away answer is 168.46. So this value here is 168.46 degrees. Perfect. And then using a similar argument, we can see that this solution here is just the same amount but moved on from our 360. So that one is going to be 360 add our 11.53. Okay, so 360 add our 11.53 is 371.53. So we found those three solutions. Okay, let's just review again. This was our principal value that came from the calculator. Using symmetry, this one was 180 take away 11.53, and this one is 360 here plus the 11.53 because it's the same gap. You could have just added 360 degrees onto that value either. There's another way of finding it. Now here's the key thing. All of these values are equal to our 2x add 60. So 2x add 60 is 11.53. 2x add 60 is 168.46. And that is equal to our 371.53 as well. So what we need to do for all of these solutions is we now need to subtract 60 and divide them by 2. So let's do that. 11.53 minus 60, and then divided by 2 is equal to that value there. Ah, yeah, but we can see that this one is out of range anyway, so we know we don't need to worry about that one. So we're now going to take 60 off the other one. So we've got 168 168.46 168.46 minus 60 divided by 2 gives us that one there. So x is equal to 54.2 degrees. And then this one here, let's do the last one, 371.53 minus 60 divided by 2 is equal to 155. So 155.8 degrees. And those are our two solutions. So we simply, that one's out of range. We simply get this value. This is our 2x add 60. So we take 60 off and then divide by 2. Reverse it to make it say x equals. And the same here. 371, take away 60, divided by 2. Okay, that is question 1 done. Let's have a look at the next one. The next one, again, now they've tried to confuse us by writing it as 50 theta add 2 theta, 50 degrees add 2 theta. But our original thetas are in between 360 and 0. We can see from the question. So we're going to have 2 times theta. So 2 theta is going to be less than 720, but greater than or equal to 0. And then 2 theta add 50 is going to be less than or equal to 770, but greater than or equal to 50 when we add 50. So that's the range of values we're looking for in this one. So let's sketch a little bit this time of cosine. So we've got two full waves plus a little bit. So there's our 2 full waves plus a little bit. Let's add on a little bit there. Okay, now, so where are our solutions? A little bit added on is going to be, say, about there. So that's our 770 degrees. 50 degrees is going to be about there. So this is the range of values in here where we're looking for our solution. And we're looking for the whole thing in this question is equal to -1. So if I draw a line on here at -1, then you can see that we have 2 solutions that we're looking for there and there. So we're going to get our calculator and do inverse cos of -1. So we're going to get the calculator, we're going to do shift cos of -1, close bracket. So inverse cos of -1, and the calculator gives us this value here, which is 180. And then we can simply say that this solution here is going to be like 1 full wavelength on. So we can just add 2 pi to that one. Or we could think of it as it is 360 add 180. Let's think about it that way, because that is 360 degrees there. And then we're adding on another 180. So we're going to do 360 add 180. That gives us that this solution here is at 540. Okay, perfect. So we found our 2 solutions there. This one's at 180. This one is at 360 add 180. And now these, remember, are our 2 theta add 50 values. So 2 theta add 50 is equal to 180 and 540. So now we just subtract 50 and divide by 2 in order to find the original theta value. So 180 take away 50 divided by 2 is 65 degrees. And our next one, 540 minus 50 divided by 2 is 245. 245 degrees. So those are our 2 values for the second one. And that's how I definitely recommend approaching these kind of questions. Third one, then we have a tan one. Tan's a little bit different. So in tan, because of the fact that tan is just like periodic and tan is just doing this, we don't typically, so tan just does this forever, okay? So we don't typically need to draw tan. And the reason we don't need to draw tan is because as soon as the calculator gives us any solution, let's imagine the calculator gave us that solution, and let's say I wanted to find this solution, all you do is add 180, add another 180. Okay, so you just add multiples of 180 to get to any other solution, or indeed subtract 180. So because you only need to add or subtract multiples of 180, it's kind of redundant drawing the graph. So for tan, we don't commonly draw the graph. We can just, because it's quite easy to work out. So let's adjust our range of values. In this case, x is less than 180, but greater than or equal to minus 90 in this case. So we're going to have 3x. So we're going to do 3 times our 90 is going to give us minus 270. So we have minus 270 degrees less than or equal to 3x, which is less than, and we're going to do the 180 times by 3 is 540. Okay, and then we're going to just add, in this case, 17. So 3x add 17 is less than, we're going to have there 557 degrees. And then here, be careful, because when we add on the 17, the number's going to get a bit bigger. So it's going to be minus 270, add 17 is minus 253. Minus 253. So there's the values that we're looking for. So we're going to find our principal value by doing inverse tan, and the angle in question, the number in question is minus 0.41. Okay, so inverse tan minus 0.41, and the calculator gives us that value as our principal value. Okay, so we found that we're getting minus 22 point, let's just say 3. So we need to think, okay, are there any values over here? So we need to subtract multiples of 180. So I take away 180, I get minus 202, which we can see is in range because we're going down to 253. But if I was to take off another 180, I would, go bust, as it were. So I'm going to add 180 again to get me to my minus 22. Add another 180 to minus 22, gets me to 157.7. Add another 180. That gets me to 337.7. Add another 180. Just keep on going until you've got all the values that are in the range. Oh, that one's close. That one's 517.7. And so I can see from there that if I was to add another 180, I would go bust, as it were, because I'm very close to the limits. So those are the values of our 3x add 17. So over here we can say this is 3x add 17 is equal to all of these values. So now finally, we just need to subtract 17 and divide by 3 from each of the values. So minus 17 and divided by 3 gives us 166.9, 166.9 for that first one. 337.7 minus 17 divided by 3 gives us 106.9, 106.9. The next one, 157.7 minus 17, and then divided by 3 gives me 46.9. Next one, minus 22.3 minus 17 divided by 3 gives me minus 13, minus 13.1. And then finally, the minus 202, minus 202.2 minus 17 divided by 3 gives me that final value of minus 73, minus 73.1. And that is our x solutions. So that is our final answer. So we solve it and we get the 3x add 17, and then we rearrange it to make the x the subject again in this case. So that's how we would solve question 3. But the key idea there is remembering to adjust the range of values that is given so that it reflects the range of values in the question. Absolutely essential, really important key skill that will be forming an essential part of much, much bigger questions moving forward, both in year 12 and year 13. Super important key idea there.